Okay, lesson 2.6. It's kind of a transition. We're going to change a few things, so we're looking at really just some basics of some parts that we need. We'll come back in the next couple of days and hit the main things, but here's just a couple little details that we need to kind of have a picture of as we get ready to graph, especially one of the new graphs we're going to do in 2.7. It's absolute value, so this is going to kind of walk us up to where we need to be for 2.7. All right, translations. It's really, if you want to think about what a translation is, this is how you shift or how you move a graph. So when we're talking about translations, this is more of moving it up and down and left and right. We could also talk about rotating it upside down or spinning it a certain different way, but mostly with translations, the main thing we're going to look at is how you move it up or down or left or right. And we're only going to look at two types of graphs for now. Once we get the basics down for these two types of graphs, then this will move into all the other types of graphs that we'll do. We'll just replace the either parentheses or absolute value with fill in the blank, square roots. We can talk about radicals. We can talk about all these other things that we're going to do. Exponents. We can talk about all these other things, but it's all going to come back to these two basic types of things. First type we're going to do is a linear graph. And that's everything we've been working on so far with slopes and y-intercepts and point slope and formula. All those things we're doing, that's a linear graph. That it's y equals mx plus b. Okay, so that part, there's not going to be anything new with that one. Now, the only thing they might do just a little bit different is instead of doing y equals, they may write it as a function where it's f of x equals. But it's the same graph, whether it's y equals or whether it's f of x equals, it's the exact same graph. So there's really no difference in those two. And here's the second graph that we're going to do. And we've talked about absolute value just a little bit when we worked on some numbers and had to plug in some numbers. We haven't talked about the graph yet, and we're going to do more of that tomorrow in 2.7. This is more just kind of getting you just the basics of what we need to do and how we're going to move around and shift these graphs. That if we talk about absolute value, when we start graphing these, we're going to basically do something like this. So it's y is equal to the absolute value of x. And same thing for the function. They could do f of x equals, and then do the absolute value of x. And again, there's, as far as how you graph these two, there's really no difference in graphing this and this. It's just this is an equation and this is a function. They'll look exactly the same if we graph them. It's just they carry a little different weight whether one's an equation and one's a function, but the graph of it looks exactly the same thing. Okay, here's the one, and if there's one big thing that we want you to get off of 2.6, and this is what we'll do with it in 2.7 and 2.8 and keep working on it, that there's really two big rules that you're going to have, two main rules that we're going to do for translations. And again, two big rules. If we get the other ones, that's fine, but the two big, huge main things that we need are basically this. If you add or subtract, depending on what the sign is, a number on the, and here's the key thing with it, if it's on the inside of the absolute value. And now if we're doing this with the linear graphs, they'll kind of spin off this one just a little bit, that they may go back and put some parentheses here. So if they give you a number that's on the inside of the absolute value, or they're going to kind of tweak it just a little bit to talk about a parentheses. So if you add or subtract a number on the inside of the absolute value parentheses, we'll say it this way, that it causes an opposite horizontal movement, which is that's the translation part. How you move it is basically the translation for this thing. Okay, and this is the one big thing you want to key on. Where is the number that we're going to work with? If it's on the inside of whatever it is that they give to you, whether it's an absolute value or parentheses, you're going to move it in the opposite horizontal direction. Okay, so that's the first big idea, the first big topic that we kind of look at for this one. The second big thing that we need here, same thing, but if we add or subtract the number and it's on the outside, okay, so second part is we're going to add or subtract number. This time it's on the outside. So if we're on the outside of the absolute value or the parentheses, it causes a vertical movement. Okay, now when with the vertical movement, it's the normal direction. Because with the inside, it went in the opposite horizontal direction. This time, when we do the vertical part, this is a normal direction. Okay, now and here's the basics of what we're going to get down to. And again, we'll kind of add to this a little bit more tomorrow and actually graph it. Right now, we're not going to do any graphs with absolute value. We'll come back in tomorrow and actually graph the absolute values. But today, I just want you to kind of get the idea of what we're doing and how this thing looks like and what all this stuff is going to do. Okay, and they can ask you a bunch of different questions and have you do some different things, but we'll kind of word it like this for the first part. And basically something like this. How does f of x, which is the absolute value of x minus 3, how does that compare to g of x, which is the absolute value of x? Okay, and here's all you're going to do for these. Here's the only thing you're going to look for. What's the difference of those two functions? Again, that's not your question. What's the only difference between the two? Yeah, 3, right? So the only difference between those two functions is the -3. Where is the -3? It's on the inside the absolute value, right? So here's all we have to do is that since the only difference between these two functions is this -3 and it's on the inside, that means we're going to move this thing in the horizontal direction, but we're going to go the opposite direction. Now, here's the part of the opposite direction. when we talk about this one, that if we had a number line where 0 is our middle, -3 is over here to the left of 0. So if we're going to go opposite direction on this case, we're going to move this thing 3 spaces or 3 units or 3 whatever we're going to call it. But we're not going to go to the left. We're going to go opposite direction. We're going to go 3 spaces to the right. And that's it. That's all you have to do. So all you're going to do is you're going to look at the 2 equations or the 2 functions they give to you, and you're going to tell me, all right, what's the difference between the 2? Well, this one's got this where this one doesn't. Okay, where is it? Is it on the inside? Is it on the outside? And if it's where it is, tells you which way it's going to go. Anything that's on the inside is going to move it left or right. Anything on the outside is going to move it up or down. Okay, with the parentheses, we'll do the same thing on this one. Sometimes they'll do the parentheses a little bit different. And we'll show you another one in a minute because they've got 2 options that they may do for the parentheses. This is one option that you may get. How does f of x, which is x plus 4 with x in parentheses, how does that compare to g of x with just the parentheses of x? Okay, and again, same thing. Just look at it and tell what's going on. This 4 is on the outside. Back here we could have kind of looked at this one and said, all right, this one, that -3 is on the inside. Well, in this case, the plus 4 is on the outside. So if it's on the outside, we're going to move it vertical, up or down, in the normal direction. So if it's plus 4, that means we're going to go 4 spaces, adding up, basically normal direction. So this is going to be 4 spaces up. 4 units up, 4 up, if you just want to kind of go for short. Alright, let's give you a couple more of those. Make sure we got it. Now here's one where they'll do the parentheses just a little bit different. Might do something like this. So how does f of x plus 7 compare to f of x? Where there's not an equation, it's just a function, and we've got the different parts of here. But it's still that same thing. What's the only difference between this and this? We've got a plus 7 that's on the inside, right? Okay, and if it's on the inside, we're going to move it in the opposite horizontal direction. So normally from 0, plus 7 would be over here to the right side. But we're going to go opposite directions, so instead of going 7 to the right, we're going to go 7 to the left. There you go. So again, it's all about the placement. Where the number is tells you what to do. If it's on the outside of either parentheses or absolute value, you're going to move it up or down. If it's on the inside of a parentheses or absolute value, then you're moving it left and right. All right, now here's where they might make you graph some of these and then talk about the difference of how this is. We'll kind of make it all tie together. They may ask you to graph y equals 2x and y equals 2x minus 3. And tell how they're different or compare the 2 graphs. Or they may word it the same thing back up here. How does y equals 2x compare to y equals 2x minus 3? All right, now, and you can do this without graphing it because now some people may say, well, what do we do? There's no parentheses and there's no absolute value, right? Okay, let's say you don't have a car yet. Can you leave something on the inside of a car that you don't have? You can't, can you? So if you don't have parentheses or absolute values, can you put something on the inside? Yeah, if you don't have it, you can't put something on the inside of it. So this one's kind of the same thing. Since there's no parentheses and no absolute value, then this negative 3 that's here has to be on the outside. So if you don't have a parentheses and you don't have an absolute value, then there's nothing you can put on the inside of it. If you don't have a car, you can't leave your phone inside your car that you don't have. So if you don't have parentheses, you don't have an absolute value, then it has to be on the outside of whatever you're doing. Okay, now again, you can do this one without even graphing it. When they ask you how it compares, this negative 3 then is on the outside. And since it's a negative 3, we're going to move it 3 units down. So if they ask you to compare them, you can compare it just by looking at it without actually having to do the graph of it. But we'll just do a quick sketch of the graphs just so we can kind of, so that you can go back and actually see it and see how it actually works there. So graphing y equals 2x. We don't have a y-intercept, so they don't tell us where to start. Start at 0. So start at 0, your slope is 2, which again would technically be 2 over 1. So we're going to go up 2 over 1 and get the next point there. So that would be our y equals 2x. Okay, and the only difference between these two graphs, again, is that this one's minus 3. So we're going to take this graph, and it's kind of the same thing. This one, the y-intercept's at negative 3. So now we're going to start down here at negative 3, which means we're going to start 3 spaces farther down, and that's where that 3 down comes into this thing, because that's the only difference of those two graphs. This one, the y-intercept's at 0. This one, the y-intercept's at negative 3. Still got the same slope, so up 2 and over 1. So if you were to graph these two lines, they're parallel. Well, if I can draw a straight line. Okay, if you think about it in like just graph form, that's kind of what they want you to see. That the only difference between these two graphs is the y-intercept, and that y-intercept is just how far up or how far down you move the graph. So if you don't have a parentheses, it's basically the same as like putting this thing on the outside of the parentheses like this. Okay, and then the last little thing that we've got to look at is they're going to talk about a vertical stretch or a vertical compression. And I think sometimes they may call this a shrink. So they may say shrink or stretch. Sometimes they use compression, so you can they're going to go back and forth on those two. But they always talk about a vertical stretch or vertical compression. And if you want to think about it this way, it's not exactly, but it's kind of like slope. The numbers that we were adding and subtracting, those were kind of like, again, moving it up and down and left and right. That whenever change the slope on those lines. If for all those examples we looked at, the slope was the same every single time. The only thing we did was we would move it up or down and left or right. Slope was always the same. This one is going to change the slope a little bit. And here's what we're going to do. Here's the big difference on this one. Because before we were adding and subtracting, for this one, for slope, that was always the number times x. So in this case, we're multiplying. So if you multiply x by some number, and for this one, we're going to call it a, just to make it, so instead of having to just keep saying some number, we're going to say a is that number. So we're going to do a times whatever it is that we're looking at. And you've got two options. If a is greater than 1, you stretch the graph. Okay, and on the other side, if that a number is somewhere between 0 and 1, if it's a half, if it's a third, if it's a fourth, if it's 2/5, if it's anything between 0 and 1, you compress or you shrink the graph. Okay, and they're going to do pretty much just one of two different things to kind of get you thinking about these. And if you want to think about it, I always tell people, think about that if you've got a rubber band and it's kind of like your 2 points, if you're graphing a point, and you had a rubber band wrapped around your 2 fingers so you could see what the line was. If I told you to move your hand, move those points twice as far apart, and you had a rubber band on here. There's our 2 points and there's our rubber band. What happens if I tell you to move your fingers twice as far apart? Stretches out the rubber band, right? So it's going to stretch out the rubber band. That's why they call that a stretch. If they tell you, all right, now take your fingers and make it so they're half as far apart, you're going to bring it together. Well, now that it's going to start to shrink because now it's compressing, it's coming back together. So when you think about those two things, and again, it's kind of like the slope because you're either going to make this slope so it's, the points are twice as far apart or they're half as close or whatever you're going to say, that you're basically taking the line, either stretching it out or you're going to shrink it, make it kind of come back and forth. So that's kind of the visual you want when you think about this one, when they talk about multiplying, and that's the stretch or the shrink, or again, sometimes they may talk about compress. Compress or shrink, they'll kind of flip back and forth on those. And they're going to pretty much do one of two options. They're either going to give you just a basic equation and then give you a new equation and tell if this new equation, y equals 5x, is a stretch or shrink. And then the second thing they might ask you to do is they may tell you what the factor is. Okay, so we were started with y equals x, And now we have y equals 5x, so we multiplied by 5, right? 5 is definitely bigger than 1, so there you go. That's a stretch. And most people like to see, I just look at it. Yeah, this is one where you just look at it. They're going to give you some equation, they're going to change it, and tell me if that number is bigger than 1, which is stretch. If it's less than 1, it's a shrink or compression. And they ask what's the factor. Well, we multiplied by 5, so the factor would just be 5. Okay. The other thing they might do is they may do something like this. They may say, given y equals x, show a compression of 2/3. Okay, so all we're going to do is we're going to take that 2/3 and multiply it by x. There you go. That's it. So if they give you a number that's a factor, you just multiply x by that number. That's all you have to do. The only thing they might do is they may give you a little different equation in the beginning. They may say, all right, for y equals 3x, show a stretch of a factor of 4. A little different wording, but basically still the same thing. It doesn't matter what the number is they give to you, whether it's a compression or whether it's a stretch or a shrink, whichever way they word it here. You basically take this number and you multiply this equation by that one. Now the 3 is already there, so it's just 4 times 3x. Well, that's just y equals 12x. So if there's already a number there in front of x, you're just going to take that number and multiply those two things together, and now you've got your new equation. Okay, so really straightforward on that one. And again, you're always going to multiply. If the number is bigger than 1, it's a stretch. If the number is less than 1 or somewhere between 0 and 1, then it's a compression or a shrink. Yeah, somebody's probably saying, well, what about the negatives? Okay, here's where they're going to kind of tie in the part with the negative, and this will be the last thing we'll do that still kind of goes into the stretch here. That negatives, those are reflections. We'll do this on one last paper here. Okay, and all that reflections are, this is if you put a negative in front of x. And it's kind of like the very first two things we did. Where you put the negative is a difference of where it's going to go. If you put a negative, it's kind of looking at it like this. Let's say we've got y is equal to f of x. So we got some equation, some function that's over on the end over here. Where you put the negative depends on how this thing does. That again, you've kind of got your parentheses here. That if you have a negative on the outside, so this would be like we had y equals negative f of x. And it's going to go back to that same thing. Where you put the negative tells you what this thing is going to do. Back here in the first part, if we had a negative on the outside, it made it go vertical. This one's going to do the same thing. It's still going to cause it to have a vertical flip. It's going to make a vertical reflection. And when you go, and think about it in this case, if you have a graph that we're doing with our, if we're graphing this thing, if you move up and down, which axis do you go over? If I go from here to here, what axis did I go over to get from here to here? You're going over the x-axis, right? So in this case, they're going to say that this causes a vertical reflection around over the x-axis. Because you're basically going to take this thing and you're going to flip it upside down. So, but they're still kind of going back to that same thing. Where that negative is, or where that number is that you work with, tells you what it's going to do. Anytime it's on the outside, it's always going to make it go vertical. It's going to make it go up and down. Same thing here. If on the flip side, if it's on the inside, so now it's on the inside of the print. In this case, it'd be on the inside of the parentheses, where over here it was on the outside of the parentheses. So if you have a negative on the inside, it causes a horizontal reflection. And if you go side to side, now you're going over the y-axis, so they would say this would be about the y-axis. Okay, but it still goes back to that same thing. Where it is tells you what to do. If it's on the outside, you're going vertical. If it's on the inside, then it's horizontal.